Hello everyone, I am Dr. Fahim Ishtaq. We are continuing the lectures for mathematics for cryptography. We will continue this lecture. Before this lecture, I suggest you must have to watch our previous lectures. Then you can better understand the next lectures as well. In this lecture, we will discuss the inverse in modular arithmetic. When we are working in modular arithmetic, we often need to find the inverse of a number relative to an operation. We are normally looking for additive inverse relative to an addition operation or multiplicative inverse relative to multiplication operation. First, we will discuss the additive inverse. Additive inverse in definition mentioned in modular arithmetic, each integer has an additive inverse. The sum of an and its additive inverse is concurrent to 0 modulo n. In Z into n, two numbers a and b are additive inverse of each other if a plus b is concurrent to 0 mod n. In Z into n, the additive inverse of a can be calculated b equal to n minus a. For example, additive inverse of 4 in Z into 10 is 10 minus 4 equal to 6. This is the additive inverse. In another example, for all additive inverse pair in Z into 10, the 6 pair of additive inverse are 0, 0, 1, 9, 2, 8, 3, 7, 4, 6, 5, 5. In this list, 0 is the additive inverse of itself, so is 5. Note that the additive inverse are reciprocal. If 4 is the additive inverse of 6, then 6 is also the additive inverse of 4. In multiplicative inverse, modular arithmetic, an integer may or may not have an multiplicative inverse when it does product of the integer and its multiplicative inverse is concurrent to 1 modulo n. For example, if modulo is 10, then the multiplicative inverse of 3 is 7. In other words, we have 3 into 7 mod 10 equal to 1. Also, an integer may or may not have multiplicative inverse. Moreover, an integer a will only have multiplicative inverse if and only if GCD n into a equal to 1. In this case, a and n are called relative prime or co-prime. Here are some examples for the multiplicative inverse. We will move forward finding multiplicative inverse using a standard Euclidean algorithm. In previous lecture, we discussed the extended Euclidean algorithm. Find the multiplicative inverse of b in Z into n when n and b are given and GCD n into b equal to 1. The multiplicative inverse of b is the value of t after being mapped to Z into n. I suggest you please watch our previous lecture where you can easily understand the extended Euclidean algorithm. This is the process for the extended Euclidean algorithm. This is the algorithms as similar we previously discussed. We will go with the example of multiplicative inverse using extended Euclidean algorithm. In this example, multiplicative inverse of 11 into Z into 26 is 26 divided by 11. We can say that 11 into 2, 22, 4 is the remainder. Then we shift R2 with R1 and R with R2. Then again 4 into 3, 2s are 8, remaining 3 is the remainder. Similarly, we will shift 4 here and 3 here. We will move until we got the 1 and 0 value. Similarly, for the purpose to get the find the value of t into 1 and t into 2, we firstly predefined value we will take for the t1 and t2 is the 0 and 1, and then we similarly perform the extended Euclidean process as previously discussed. 0 minus 2 into 1, which is minus 2. Then we shift the value 1 t2 is to t1 and t into t2. Here we can say 1 minus 2 into minus 2, which is 2 into 2, 4 plus 4. 1 plus 4, which is 5. Similarly, we will shift the value and we will do the same process until we reach the step where we stop 1 into 0. We can say that GCD of 26 into 11 is 1. The inverse of 11 is minus 7 or 19. Okay. Here the another example for the GCD. Thank you so much for the today lecture. We will come up with the next lecture.